Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM Trial paper for the year 2024. And this is the MRSM paper 2. Okay, let's begin with the first question. This first question is from Form 4 Chapter 1, Function. So you're supposed to find composite function gf10, you're given function fx, you're given function gx. So gf10 means we start by putting 10 inside fx. My fx is x minus 5. So in this case, it's 10 minus 5. 10 minus 5 is going to give us 5. I'm going to put 5 inside your g. So this is 2 over 5 minus 1. 5 minus 1 is 4. 2 over 4. Answer is just 1 over 2. All right, that is part A. So part B diagram shows the graph of function y equals kx for the domain of x greater equals to p. You're supposed to sketch the graph of function hx in diagram 1. Yeah? Given that hx is the inverse function of kx. So remember, the relationship between a function and its inverse graphically is a reflection in the line y equals x. So first we draw a slanting line that passes through the middle. This line is y equals to x. Okay, so when you reflect, right, this point will be over here, P. You draw a reflection like this. Okay, so this is y equals to h x. Yeah, hx is the inverse of y equals kx. Okay, now next thing is we need to go and find the domain. The question say domain, state the domain of hx. Okay, hx, right? If you can see, it is on the right hand side of the y-axis. Everything else on the right hand side, right? None of graphs on the left hand side. At the same time, your domain does include p, so it is greater equals p. So when you reflect over, it does sit on the y-axis. So you need to consider x equals to 0. Okay, so your possible x value, which is your domain here, is everything from 0, this is 0, y-axis is 0, to the right-hand side. So that's why the domain is just x greater equals to 0. Okay, now next, given that function kx is square root x minus b, and point A, A, comma 8 lies on the curve hx, express A in terms of b. Okay, well, when point A lies A8, A8 meaning it could be probably here. This is A8. When it lies on the curve y equals hx, right? And you're given the function kx. So what we can do is, to make it easy, we just take this and reflect in the line y equals x. When you reflect over, this point on kx is not A8, it is 8A, where your x and y now interchange. So using this result, I'm going to take this and sub inside. Okay, so if you want, you can explain like this. So point A8 lies on hx. Okay, therefore point 8A lies on kx. Yeah, y equals kx. Maybe I write here the graph y equals to hx. This is the graph y equals to kx. Now with that, we can sub in the coordinate. Take this coordinate 8 and a, put inside your function kx. So your y is your kx here, is now a equals to square root. Your x is now 8, u minus b. There you go. You got your expression for a in terms of b. Very simple, right? The moment you reflect over, do you need to find the inverse function? No need. You just have to switch the a and 8, the x and y, then you sub in the function, you will get an expression for a in terms of b. Okay, moving on to question number 2. This is from Form 4, Chapter 7, Coordinate Geometry. So here we have a diagram that shows the position of Ahmad's house, the school, and Chang's house, which are located on the straight road A, B, C here. All right, so Ahmad and Chang cycle from their houses to school at a speed of 4, 14, and 21 km/h respectively. They left the house at the same time, arrived to school at the same time. So find the correct point C. Okay, so here's the thing: speed equals to distance divided by time. So in this case, they travel at the same time, right? But they reach school at the same time. So if you take speed equals distance divided by time, so your time is constant, so your speed is proportional to the distance traveled. So if Chang travel at the speed of 21, Ahmad traveled at the speed of 14, and they reach here and here at the same time, meaning the distance for Chang's house must be proportional to the compared to Ahmad's house must be proportional to the speed that they cycle. So we can just use simple ratio and divide everybody, in this case, by 7. When you divide by 7, right? So the ratio m is to n. You can say a b to bc. The ratio is 14 is to 21. If you divide by 7, you get 2 is to 3, meaning this is 2, this is 3. Now, we don't know exactly where is the location of Chang's house, so I'm going to let C be xy. So we're going to use a ratio formula. B is a point that lies in between 4 minus 1. You let it be n. Remember, the formula nx1 mx2 over x, let me write here, n nx1 mx2 n plus n followed by ny1 my2 m plus n. The most important thing about using this formula is that the ratio and the coordinate must be opposite. So we already let x be c be xy. So this will be 2 multiplied with opposite coordinate x, 3 multiplied with opposite coordinate 8, total ratio 3 plus 2, or you can write 2 plus 3. I think I'll write 3 plus 2. So then we take 2 times y, then you add with 3 times -5, total ratio 3 plus 2. So let's compare. 4 equals 2x plus 24 over 5. Then -1 equals to 2y minus 15 over 5, multiply over 20 equals 2x plus 24. 2x is -4, x is -2. -5 equals to 2y minus 15. 2y equals to 10, y is just 5. So therefore, coordinate point C is -2, 5. Okay? All right, that is the first part. Next, a mosque is located at Jalan Bakawali. On Jalan Bakawali, the coordinate is h -2. The road parallel to road AC and intersect. The road is parallel to road AC and intersect the x-axis at h9. So let me just do a sketch. So your Jalan Bakawali is parallel to AC and it intersects the x-axis at xy. So I don't know, at x-axis here, at negative, this one is 9, 9. Now, then they say that the mosque is at this position h -2. So h -2, I assume is around here. H -2. This is the mosque. I can put it M, right? So we are supposed to determine whether the pathway is the shortest pathway between the mosque and road AC. So if it's a shortest pathway, right, that means this should be perpendicular. Now, we do not know whether it's perpendicular or not. First, we need to know what is the value of H. So we know that if this is perpendicular, okay, first of all, they already say these two are parallel, right? So we need to form equation of this line, right? We find the value of H by comparing the gradient of this line with the gradient of this line, okay? So maybe we find gradient of AC. We know gradient AC must equals gradient M2. M2 represent the second line, the line where the most is located, right? So AC, we can use, or AB, right? We use AB better. I'll use coordinate point B because in case your C is wrong, then I can still get the correct answer. I'm using point B and point A. So let's do y2 minus y1 divide x2 minus x1. For M2, I'm going to use -2 minus 0 over H minus 9. So this is -5 plus 1. which is -4. -4 divided by 4, you get -1. This is -2 over h minus 9. So let's cross multiply h minus 1. H minus 9 equals to +2. H is just 11. So you know the coordinate point, the MOS already is 11 minus 2. Now, to know whether it is a shortest distance, we know you have to test whether it's perpendicular. Remember, perpendicular, shortest distance from a point to a line is the perpendicular distance. So this will be perpendicular. We want to know whether it's the shortest distance to Ahmad's house, right? So we will take, they say the new pathway to be built connecting MOS and Ahmad's house. Ahmad's house is here. The MOS is here. So we're going to test whether this line is perpendicular or not. So let's find a gradient of AM, the MOS, let it be M, right? So gradient of AM, you look back at the coordinate. So by the way, your M, right? Let me write here, your M is now 11 minus 2. Gradient of AM will be, let me start with -2 minus -5 divide by 11 minus 8. So this is 3 divided by 3, which is just 1, right? Okay, then we test with the gradient AC, right? AC is this line. AC is this line, right? Well, you can, AC and this gradient also, they are the same, they are equal. So they share the same gradient, which I really know, gradient AC, I really know. Gradient AC from here, it is -1. Yeah, let me highlight for you, -1 here. So we can see this is gradient AM. So we just take gradient AC multiply with gradient AM, see whether they are perpendicular or not. So it's -1 times 1, you can see it's -1, right? If two gradient multiply together equals -1, meaning they are perpendicular. If they are perpendicular, meaning it will be the shortest distance. So how do you explain? Yes, they say the pathway is the shortest pathway, yeah, between the MOS and road AC. That's all. Okay. Okay, moving on to question number 3. This is Form 4, Chapter 2, quadratic function. A quadratic equation has roots of alpha and beta. So find alpha plus beta, alpha times beta. This is fairly simple. We know that your SOR, alpha plus beta, is -b over a. My a is -2, my b is -7, my c is 5. So your b is -7, a is -2. Answer is just 7 over 2. Negative. Okay, then let's work on our POR, product of roots. Alpha times beta is c over a. C is 5, a is -2. Leave it as -5 to a, right? We got these two answer already. Now, next, form a quadratic equation with the roots of alpha plus 3 and beta plus 3. So this is what we call our new SOR, okay, new sum of roots. We take alpha plus 3, we add with beta plus 3. So this is going to give us alpha plus beta plus 6. My alpha plus beta is -7 over 2. I add with 6. 2 times 6 is 12. 12 minus 7 is 5. Answer is 5 over 2. Now let me continue my POR here. My POR, new POR, will be, we take alpha plus 3, multiply with beta plus 3. As we expand, you get alpha beta plus 3 alpha plus 3 beta plus 9. So here we can factorize it. We take out 3, left with alpha plus beta plus 9. Your alpha beta is -7 over 2. My alpha beta is -5 over 2. My alpha plus beta is -7 over 2. So from here, we can just sub in. This is your alpha times beta. This is alpha plus beta, right? Okay. So we will simplify further. Can you use your calculator? So let's just count. This is -5 over 2. -5 minus 21 over 2. I'll just put them together. Then you plus 9. Answer is -4. That's my POR. I've got my SOR. I've got my POR. I just want to form a new equation. Your new equation is given by x squared minus your SOR, sum of roots, 5/2x plus your PRR, -4, equal 0. Now here we can multiply everybody by 2, get a fraction. So 2x squared minus 5x minus 8 equal 0. Okay. All right. That is part A. Okay. Now let's move on to part B. So for part B, you have a quadratic equation. It has two real and equal root. When they have real and equal root, we know our b squared minus 4ac must equal to 0. And we're supposed to express m in terms of n. So let's expand the bracket. This will be 6x minus 9x squared equals to m plus n. Rearrange it, bring it to the right-hand side. 9x squared minus 6x plus m plus n equals to 0. Okay, applying your b squared minus 4ac here, I know my a is 9, my b is -6, my c is m plus n. So b is -6 squared, a is 9, c is m plus n. The result equals to 0. Okay, so -6 squared is 36. This is also 36. 4 times 9 is 36. M plus n equals 0. For me, I'll divide everything by 36. So 1 minus m plus n equals to 0. Bring it over. 1 is m plus n. You're making m, Malaysia, as a subject. Malaysia is 1 minus n. Yeah. Netherlands. Yeah. M equals 1 minus n. There you go. Okay, question number 4. So here we have a geometric progression such that the 7th term is 3 times the value of the 6th term. So 7th term is T7 is 3 times the 6th term. So your 6th term is T6. So from here we can use the formula for geometric progression. Tn is a r n minus 1. So we write a. Your a, we do not know exactly what is it, but your common ratio is r power 7 minus 1, you can write 6. This is 3 times a of r power 5. In fact, you don't really need to do this because we know T7 divided by T6 is just your common ratio, right? It's okay, I'll just write this. It's 3 times. So when you divide it, r power 6 divided r power 5, r is just 3, right? So this is the first part. Find out what is your common ratio of this progression. Now, you're supposed to show that the sum of the first 4 terms is 10 times the sum of the first 2 terms. Sum of the first 4 terms is given by a. Your r is 3 power 4 minus 1 divided by 3 minus 1. Now, 3 power 4 is 81. 81 minus 1 is 80. 80 divided by 2, you get 40. So it's 40a. Then you find out the value, the sum of the first 2 terms. S2 is, in this case, is a, bracket. Your r is 3, right? So it's 3 squared minus 1 over 3 minus 1. 3 squared is 9. 9 minus 1 is 8. 8 divided by 2 is 4. So your S2 is 4a. Now, we're supposed to show that your S4 is 10 times of S2, which is true, right? So we can just take S4 divided by S2, which is 40a divided by 4a. So if regardless of whatever value of a that you have, you can cancel them, right? Let me cancel here. 40 divided by 4, you get 10. Therefore, S4 is 10 times of S2. Yeah, that's how we show it. All right. Moving on to question part B. So this one you have 3 kites. They say the diagram shows the arrangement of first 3 kites of the infinite series of similar kite. So the first kite has diagonal of 50 and 45. Measurement of diagonal, subsequent kite, they are half of the previous one. So, and this area form a geometric progression. So we can use the formula for area kite, which is half product of the length of 2 diagonal. So your diagonal is 50 and 45. So the area of the first one, right? This is part B. Never mind, I'll just write D1 is half of 50 times 45. So 50 times 45. Let me just use a calculator. Half of 50 and 45. 50 and 45. You should get 1125. Okay. Right. So you're supposed to find out, okay, let me write down here. You're supposed to find out the first term and the common ratio. We already got your first term and your common ratio. Maybe I write a bit lower because it's very hard to see, right? Yeah. Okay, let me write here. Your first term is half of 50 times 45, which is 1125. Then you're supposed to find the common ratio. Now, actually, I can tell you the common ratio is 1/4. Yeah, because the question asks us to state only. A state only, actually, by right, you don't need to show any working. But if you prefer, I will just write E2 for you. The second one is 50 divided by 2. Why? The length is now half of it. You can write 25 and 45 divided by 2. So basically, it is 1125 divided by 2 divided by 4. So yeah, 1125 divided by 4. Because this part here, you can see, it is 1125. This is 1125. You just have to divide by 2 twice, right? So your common ratio is D2 divide D1, which gives us 1/4. All right. Now, hence, we're supposed to find sum to infinity of this area. Yeah, very simple. Sum to infinity is given by first term A divided by 1 minus R. Your A is 1125. 1 minus your R is 1/4. So use your calculator. 1125 divided by 1 minus 1/4 is 3/4. There you go. My answer is 1500. Yeah. Okay, question number 5. So this is from, actually it's considered simultaneous equation. So, but you need to form the equation first. You have to solve equation of straight line and a curve to find the coordinate point Q and R. So you notice that your straight line here passes through this coordinate -1, 0, and 0, -2. So this represents your x-intercept and your y-intercept. So you can use this formula, x over a plus y over b equals to 1. Remember, a is your x-intercept, b is your y-intercept. It is faster that way. So your x-intercept is -1, your y-intercept is -2, the result is 1. For me, I'll multiply by 2 first. So this will be -2x minus y equals to 2. Make y as a subject, bring the y to the right-hand side, bring the 2 to the left-hand side. Your y is -2x minus 2. We call this equation 1. So your equation 2 is your x squared, y equals x squared plus x minus 12, equation number 2. Let us sub equation 1 in 2 or 2 in 1. Let me write 2 in 1. Your x squared plus x minus 12 equals -2x minus 2. Bring over x squared plus 3x minus 10 equals to 0. What is the factor of 10? 5 and 2. Okay, so we can do x 5, 2 plus minus. So my x is either 2 or -5. So take these two x value and sub inside equation number 1 so that we can find the coordinate point, the y coordinate of point Q and R. So your y is now -2 times 2 minus 2, which gives us -2. Second one, -2 times -5 minus 2, which gives us 8. So we're going to decide which one is Q, which one is R. Q has the negative x value, which means the x value is -5. Positive y value, your y value is 8. And your R lies on the right-hand side. So it has a positive x value, which is 2, and negative y value, which is -2. There you go. Q is -2, -5, 8. R is 2, -2. So sorry, I made a mistake here. This is -4 minus 2 is -6. So your R is -6. R is not -2. The y coordinate is -6. So yeah, R is 2, -6. Okay, question number 6. You're supposed to prove that secant theta minus sine square over cos theta equals to cos theta itself. Okay, let's begin with the left-hand side. We always start with the side with more number of terms. In this case, the left-hand side. Secant is 1 over cos. Then you minus sine square over cos theta. So since they have the same denominator, you can put them together as 1 minus sine square over cos theta. And from the basic identity, we know that cos square plus sine square is always 1. So if I transfer this over, my cos square is 1 minus sine square, right? So your 1 minus sine square is now cos square. You divide by another cos theta. You can cancel them, and you will get cos theta, which is the same as your right-hand side. Okay, now that's part A. Moving on to part B, we're supposed to sketch a graph. Now, notice that the entire thing here is not exactly the same, it's similar to what we have. Okay, let me highlight the English version. You can see this whole thing is similar to the one above, just that you have a 2 in front. So we know the secant theta minus sine square theta over cos theta will give us cos theta. So, however, we have a 2 in front of your theta. So when you want to sketch this graph, number one, you will have to simplify this, as in use the result from the earlier part. We know this entire thing is cos. However, because you have a 2 in front of theta, just add a 2. Yeah. So we are sketching the graph of y equals to cos 2 theta. So let's draw. Okay, let's draw over here. Okay. So my line is not very straight. Okay, something like this. This is 0, maximum 1, minimum -1. So I hope you know that when you draw a basic cos graph, right, it has only one complete cycle from 0 to 2 pi. The moment you have cos 2 theta, you double the number of cycle, 1 cycle, 2 cycle, it is up to 2 pi. But your amplitude remains the same as 1, maximum 1, minimum -1. So here we have to subdivide into 8 parts. So up to you how big you want to draw it. So I just subdivide it into 8 parts. Okay, so we begin from here. I like to map the point first, so we always get a nice looking and a balanced graph. Otherwise, your graph, without drawing all this, right, without plotting the points, sometimes your graph will be a bit too big, too small, too fat, too thin, and so on. So or not balanced. Okay, so try to make sure it passes through all this point. So this is the first graph, first cycle. Continue with the second cycle. Okay, there you go. My graph of y equals to cos 2 theta is done. So this is 2 pi. This is pi. This is pi over 2. This is 3 pi over 2. Yeah, you don't have to subdivide all. You don't have to label every single one. Just the main one will do. In this case, the main one that the basic for pi over 2, pi, 3 pi over 2, and 2 pi. Okay, my graph is done. Now, next, they say straight line y equals m theta -1 does not meet this graph. So find the range of values of m in terms of t. Yeah, but they say it doesn't meet at this range between between pi and 2 pi. So if you look at this, y equals to m theta -1, that means your y-intercept is -1. So you have to draw a line that starts from -1. Your y-intercept -1. Okay, so let me use a straight line from here. So you notice if you draw here, right, maybe I should move my -1 a bit lower, and this -1 a bit too high up. So if I draw somewhere here, it will touch a 1 point, right? So it cannot meet from pi to 2 pi, but it can meet elsewhere. So we can also have something like this. You see, it can meet here, it can meet here, it can meet here, no problem, but it just cannot meet from here on, okay, from 2 pi on. So we look at the maximum here. Maybe this part, right, I can adjust a bit because it should be, yeah, actually in actual fact, right, it will somehow intersect before the pi, before the peak. Yeah, it will not, unless this line, right, is here, or should I say here, right? It will touch at the peak. But you come from below, right? It will surely intersect earlier, right? But anyway, we're just assuming that it will touch or meet at the peak here, right? So actually, I would say it's a flaw in the question, right? You notice that if no matter how you draw, it surely will meet earlier before the peak here. Okay, so anyway, we assume that this is true. So you have two range that you have to consider. I think the easiest one to consider is -1. At y equals to -1, meaning what's your m? This will be what? The equation will be m theta minus 1. Your m should be 0, right? So it will not meet the graph if it is below here. Let me just show you here, right? At -1, where the gradient is 0, it will touch at 1 point. If it goes lower than that, it has no intersection. Yeah, it will not meet. So this will be your lower end. That means your m will be 0. Okay, let me just say your m the graph, this graph, we'll just write m lah. M should be 0. Should I say at y equals to -1 meets the graph when m is 0, right? Or should I say y equals to m theta minus 1 m 0? This is 1 point. So your m should be less than 0. It doesn't meet. Okay. Now, at the same time, you can also have the graph. Like I said earlier, it touches here. It will be, this is the minimum. Anything more than this gradient, it will not meet. Anything less than this gradient, in between, it will meet, right? Okay, so, okay, this one I can delete. So at this point, right, what is the coordinate? This coordinate is pi and 1. So the gradient for this part is 1 minus minus 1, pi minus 0. You have to take this point, and this point, answer is 2 over pi. So y equals m theta minus 1 meets the graph again, meets the graph, right, when m equals to 2 over pi. So your range, right, the range will be either m less than 0 or m more than 2 over pi. For these two values, you will not meet the graph. Okay, between pi and 2 pi. Okay, question number 7. Yeah, part A. This is from the chapter integration from 5, chapter 3, at least for part A. Yeah? Part B is differentiation. So here we have a beaker of iodine with temperature of 180 is left to cool at this rate, such that T is temperature of the iodine, T is time in second for the cooling process. So find the equation of T in terms of small t. T is, capital T is temperature, small t is your time. So find the equation. So I think we can just integrate this. When you integrate your dt dt, you will get the temperature T. So this minus 70 T plus 1 square dt. Now I'd like to use a what do you call it, reciprocal composite function. I know a lot of you probably bring the whole bracket up, integrate, bring it down. So, but this is a shortcut. It's a faster way to integrate this, right? So that is, we add a negative in front, copy k, copy ax plus b, reduce the power by 1, put the reduced power in front, and differentiate inside. Okay, right? So it's a faster way, but if you want to bring up, integrate, bring down, it's the same thing, right? So you put a negative in front, it automatically becomes positive 70, copy t plus 1, reduce the power by 1, differentiate 1t, you get 1. I mean, reduce power put in front, differentiate 1t, you still get 1. That 1 you don't have to write, okay? So last C. To find the value of C, right, we substitute this when T equals 0, when you start, right? Because the question says left to cool. So at the starting point, when you start the clock, your temperature is 180. So we put 180 equals 70, 0 plus 1 plus C. 180 minus 70 is 110, C is 110. So your T is 70 over T plus 1 plus 110. Okay, there you go. You got an equation of capital T in terms of small t. All right. Now, then they say, iodine is an element that exists in a liquid state when the temperature is above 113. So find a minimum time for it to exist in solid state. So it's in liquid form. So when you cool down to temperature less than 113, then it becomes solid. So what we can say is you want your T to be less than equals 113, right? So we begin by taking 70 over T plus 1 plus 110, let's equal to 113. 110 you bring over, you will get 3. Bring the T plus 1 up, bring the 3 down. So your 70 over 3 is less equals to T plus 1. So T is greater equals to 70 over 3. 70 over 3 minus 1. So as you minus 1, you will get 67 over 3 or 22.5. So now, question, they say find a minimum time. So when it's greater equals 22.5, right? Well, we have to, it's greater equals, it does equal. So the minimum time is just 22/1/3 in second, right? You don't have to round off unless the question say time to the nearest second. So if they say time to nearest second, then you take 23 because it's greater equals to 22.5, 1/3, 22/1/3. So, but because the question didn't mention that you have to use nearest minute or nearest second, sorry. So we'll just take 22/1/3. Okay, moving on to part B. There is a second part to this. This is from the chapter differentiation. So the cost of the manufacturing cost of X pieces of t-shirt in the factory is given by this. This is a cost, and the selling price is 100 per piece. The management set the profit target of 200,000. So using differentiation method, determine whether factory is able to achieve the target. Okay, so remember, simple concept of profit equals to sales or selling price minus cost. So the target is to sell X pieces of shirt, right? And the price is 100 ringgit. So maybe we call it profit function, PX. It is your sales. Each piece is shirt is X, is 100 ringgit, the selling price. So if you make X of it, so it's 100X, you minus your cost. Your cost is 100,000 plus 50X plus 0.0025 X squared. So let's just subtract and simplify. 100, if you minus 50, I'll just write 50X minus 100,000. Then you minus 0.0025 X squared. So when you differentiate, you can write dp dx, right? Or you can put p prime x. This would be like 50 if I differentiate 50x, differentiate is 50, 100,000 you differentiate, it is 0, it's a constant, and 0.0025 if times 2 is 0.005x. So at the minimum or maximum, because you want to check whether your maximum profit, can you hit a maximum profit of 200,000? So we let dp dx be 0. We find the number of shirts that you need to make to be able to get the maximum profit. So let's rearrange it. 0.005 x equals to 50. 50 divided by 0.005. Let's take 50 divided by 0.005. You should get 10,000, right? Okay, so if you make 10,000 shirts, right, you should be able to reach a maximum profit. Okay, but to find that maximum profit, we have to take this and sub inside your profit function. So when X is 10,000, you have 50 times 10,000 minus 100,000 minus 0.0025, 10,000 square. Okay, let's count. Huh? We use calculator. 50 times 10,000. You minus 100,000. You minus 0.005 times 10,000 square. Oops, did I make a mistake here in my 10,000 square? This is 50. Okay, this is 0.0025. So it is 50 times 100,000 times 10,000 minus 100,000 minus 0.0025 times 10,000 square. You get 150,000. So the maximum profit you can get is RM 150,000. However, the profit target, right, is 200,000. So can you achieve the profit target? No. Yeah, it's less than 200,000, right? So we say, will the factory be able to achieve the target? You say no. Just say no, or we can just say the factory will not be able to achieve the target. Okay, that's all. Okay, this is question number 8. This is from the chapter vector for chapter 8. Okay, here you have a quadrilateral PQRS such that T is the midpoint of PS, so these two are equivalent, and PQ, SR are parallel. So basically it's a trapezium such that SR is 2/3 of PQ, PQ is 9U. If PQ is 9U, then your SR is 2/3 of 9U. That gives us 6U. Okay, next, I know PT is 6V, then TS is also another 6V. Okay, now we are supposed to first express QT in terms of U and V. So to go from Q to T, right, I can go Q to P, P to T, right? That is 9U plus 6V. Okay, let me just write it down. Okay, answer is minus 9U because I'm going in opposite direction. Minus 9U plus 6V. You can rearrange and put 6V in front, minus 9U at the back. Doesn't matter. Okay. All right. Next, I want to find PR. So from the diagram, PR is P to S, S to R. P to S is 12V, S to R is 6U. So 12V plus 6U. Okay, so first part, we're done. Now then you see, by using PW equals to KPR, QW is HQT. All right, find the value of H and K. Yeah? So PW is now P to T, T to W. Why do I do that? Because, okay, I want to use, okay, I can go two ways. One is directly, another is this way. Okay, why do I do this? Why do I go this direction? Because PW equals KPR, so that means I need to use is K, right? It's K times a PR. The other one, I go the other direction because I'm given QW equals HQT, so this is H, right? QW is shorter, QT is longer. So if you want to find PW, you can go first KPR. We know PR from Roman 2, which is 12v plus 6u. Now I'm going to rearrange it. I'm going to put u in front, v at the back. So it's 6ku plus 12kv. Okay, this is not your answer yet. This is just the first part. The second version of BW will be if I were to go through QW. So we go B to Q, Q to W. B to Q is 9U, Q to W is HQD, yeah, given here. So we're going to use the result from the first part. QT, we know. QT is minus 9U plus 6V. You can put this together. This is 9U minus 9HU plus 6HV. Factorize it, 9 minus 9HU plus 6HV. Okay, so I got two versions of BW. What I would do is I would compare them. Now, the first version, you can see the coefficient of U is 6K. Second version, coefficient of U is 9 minus 9H. Right, so let's just compare. We compare the coefficient of U. 6K is 9 minus 9H. We can divide by 3. So 2K is 3 minus 3H. I don't know what to do. I'm going to leave it out. Right. The second version we can compare is this coefficient of V. You can see that, let me write compare V here. 12K is now 6H. H is 2K. Yeah? You divide by 6. Call it equation 2. So as we sub equation 2 inside equation 1, 2K is now 3 minus 3H. H is 2K. This is 6. 6 bring over, you get 6 plus 2, you get 8. 8K is 3. K is 3 over 8. Now let's just sub inside equation 2. Find your H. 2 of 3 over 8. Answer H is 3 over 4. All right. Now, we still have to do the last part. They say, given that magnitude U is 5 units, area of triangle is 135, find the shortest distance from W to PQ. So let's look at the diagram again. They give us area of this triangle is 135. And the magnitude of U is given. You're finding the shortest distance. Shortest distance is the perpendicular distance, yeah, from W to line PQ. Okay, so let us use formula for area triangle. Half times base. Your base will be PQ, which is 9U. Your height will be the shortest distance. I'm going to call it H here. Sorry, this H is different from the other H here. You know, it's a height of the triangle. And your area is 135. Now, we know 1U is 5 units. So you got 9U. So that will be 9 times 5, 45, times H equals to 135. To find H, right, we take 135 times 2, which is 270. Then you divide by 9, divide by 5, divide by 45. That will give us 6. Yeah. So the shortest distance from W to PQ is just 6 units. Okay, question number 9. This is from the chapter integration, probability distribution, chapter 6, form 5. Okay, so the diagram shows the graph on the normal distribution graph for the mass of pineapple harvested from orchard with mean of M, standard deviation of 0.12. So pineapple with a mass of 1.26 to 1.68 will be exported overseas. Remaining will be sold in the local market. So find the value of M, given that the percentage of pineapple chosen randomly with at random with mass greater than 1.68 is 0.82. Okay, so let's start by writing this at Px greater than 1.68. It is now equals 0.0082. 0.82% in probability is you just have to divide by 100. So it's 0.0082. Okay, to find the value of M, right, we got to change from X to Z. You got to standardize it. So when you standardize 1.68 minus mean M, standard deviation is 0.12. The result is 0.0082. Okay, so you can see this is on the right-hand side. We don't need to sketch a graph because based on the graph, you can see it's over here, right? So what I need to do is to read backwards from your mathematical table. Okay, so if you, or you can use calculator. Now, let me just use a mathematical table from this paper here, 0.0082. Let me just find it here, the last page, 0082. You have to slowly find. That's very annoying, 0.0082. It should be here, 2.4. You see? 0082. Okay, so this is one way of doing. Another way is by using your calculator. I'll show you the calculator method as well. Okay, so where will be? Here. So if you use calculator, right? If you use calculator, you need to press menu 7, go to number 3 inverse norm. Okay, then you put your area as 0.0082. You should get 2.4. Yeah, but in your calculator, you see negative, but it's negative because the calculator read from the left-hand side. So you just ignore the negative. Yeah, take answer correct to 3 decimal point will do, because your z value cannot be more than that. From the mathematical table, it's only up to 3 decimal point. Okay, all right, so it's 2.4. So let me just continue. 1.68 minus m divided 0.12 is 2.4. So multiply this over. Okay, 0.12, sorry, go back to this, 0.12 times 2.4, that will give us 0.288. I'll do very slowly here. 1.68 minus m is 0.288. So your m is 1.68, 1.68 minus answer. I got 1.392. Yeah, 1.392 is correct for SF. Yep. Okay, now next, with that, let's do the next part. So find the probability that pineapple chosen at random to be exported overseas, right? So if you want to export overseas, this is the region, right? You want to find this probability. We already know this probability is 0.0082. We need to find this part here. So you can say the probability is 1.26 to 1.68. Let's standardize this. The 1.26, you must minus 1.392 over 0.12. Whereas this one, actually no need to count really, because we know it's 2.4. The moment it's standardized earlier, you should get 2.4. So you don't have to recalculate. You want, you can sub inside 1.3 and 2, you still get 2.4 anyway. So I'm going to take 1.26 minus 1.392 divide 0.12. Okay, I got negative 1.1. So this is negative 1.1, z 2.4. I just have to do 1 minus. As you can see, 1 minus the lower tail, which is the yellow part, and the upper tail, which is the green part, okay, to get the area in between. So 1 minus bz, I flip the negative side to the right-hand side. So you will get 1.1, and then the second one is 2.4. Now, the 1.1 we need to find, okay? Again, now you can use your mathematical table or calculator. Okay, I think I'll show you calculator. Menu 7, go to number 2, normal inverse, normal distribution. Lower is 1.1, upper will be 999. Okay, you should get 0.1357. Okay, let me see again. Lower 1.1, upper 999. Yep, press equals 1357. Then for 2.4, we already got earlier. The area just now we got 0.00082 is already given here. Just change to decimal 0082. So use your calculator here. 1 minus 0.1357 minus 0.0082. You should get 8561. 0.8561. Okay. All right. Lastly, find the number of pineapple sold in the local market. If the farm, the orchard produces 3,000 pineapple. So we already know the probability for export. So in the local market is either the yellow part or the green part, right? So local market, I just put PL, is 1 minus 0.8561. This will give us 0.1439. Okay, so this is the probability the pineapple is sold in local market. Remember, the number of a pineapple sold in local market divided by NS. NS is the size of the sample space, will give us the probability, right? PL. You're finding NL. Your total number of pineapple produced or your sample space is 3,000. This is 0.1439. So take this answer. This is 1439. You multiply by 3,000, you should get 431.7. So your NL is 431.7, but we don't take 0.7 because it's number of pineapple has to be a full number. We just take the nearest integer, 432. Yeah. So the number of pineapple sold in a local market is 432. All right, this is just the first part, the one involving normal distribution. The second part involving binomial distribution. Okay, so here we have a survey of people in the class, the number of people in the class, found that 20 out of 50 likes to play football. So sample n people is chosen at random, find the probability. If the probability none of them like to play football is this, find the value n. Okay, very simple. Very straightforward question. None of them like to play football is 729 over 15625. Okay, so this will give us NC0. Your probability of them like to play football is 20 over 50. So for 20 over 50, right, I will simplify it to 205, or you can write 0.4. Okay, so it's 2 over 5 power 0. That is like to play football. Don't like to play football is 1 minus 205 is 305. N minus 0. The result is 729 over 15625. Now NC0 is 1. 205 power 0, so 1. You're left with 305 power n, 729, 15625. Okay, from here on, we use our calculator, trial and error. We take, maybe I put a bracket here, 3 over 5, bracket power, you can try power 6. Yep. If not, you just try 1 by 1. I know it's power 6 because 729 is 3 power 6. Okay, so we just rewrite here. You can write this as power 6. By comparison, we got n equals to 6. Okay, hence, find the probability that at least 2 of them do not like to play football. Okay, so we know the probability that they like to play football is 205. So maybe it's better we redefine it. Now it is a binomial with, for those who do not like to play football, don't like to play football, the probability is 305. Yeah, your n is still 6, probability is 305. Okay, you don't have to write this. We want the probability that at least 2 do not like to play football. At least 2, we do 1 minus 0, 1. Okay, that's faster. So let's do 1 minus 6C0. P is 305, power 0. Q is 6 minus 0 here. Then 6C1, 305, power 1, 205, power 6 minus 1. So again, this one you can use manual calculator, or I'll show you the fast way. Manual way is 6C0 is actually 1. If you want, you want to type, you can type. I don't type because it's easier to take this 205. 205, I can think 0.4 faster. Power 6. Then 6C1 is just 6, right? 305 is 0.6. And then 0.4, power 5. Answer is this, 9590, 0.9590. 9590. Okay. You can also use a calculator to validate. Now, this is how I do it. I press menu. There are 2 functions in your calculator that you can use. One is the normal one, as in you go to number 7, you go to binomial PD number 4. So you can go to list. List means you list out all the possible probability that you can find, like X can be 0, in this case 0 and 1, right? Then you go and put your N is 6, and P, your probability of success in this case is 305. Then you get these two values. So you're actually getting the first one. This is 0.00496. Meaning you add in here 0.00496. Okay, that's the first answer. Second answer is 0.03686. 0.03686. Then you do 1 minus to get the answer. All right. A bit slower, but can still work. Okay. The second method is you press menu, go to 7. Instead of using binomial PD, we move down, you go to binomial CD. CD simply means cumulative density. That means you count up to, right? So if I want greater equals to 2, I must minus 1, I must minus 0 and 1. Probably 0 and 1. So you go to variable 2, binomial CD 1. 1 means 0 and 1 add together. It's like your normal maths cumulative frequency is cumulative. You add together probably 0 and 1 together. Your N is 6, your probably 0.6. So you get this answer, right? Okay, wait. This is CD, and P 0.6. Okay, it's correct. So yeah, as I do 1 minus of this, okay, 1 minus 0.04096. Okay, let's go back to 1 minus 0.04096. You should get the same answer, 9590. Okay. Okay, question number 10. This is from the chapter integration. So here we have a curve, y equals x, bracket 6 minus x, straight line ON and N, they are both tangent to the curve at point O and M respectively. So you're supposed to find coordinate point M. N. So number one, you can see this is actually a quadratic, and it is symmetrical at this line here. So we can first find where is the x coordinate. We know, actually I can tell you this is 3, but I just show you the working. How do I get 3? We know at x-axis your y is 0. Okay, your y is 0. So we will take x of 6 minus x, let it be 0. Your x is either 0 or 6. So obviously origin is 0. Your M will be 6, 0. Now, if you find the axis of symmetry, 0 plus 6 divided by 2, your x value is 3. So we know this line is x equals to 3. It's a vertical line. Okay, so your x coordinate point N should be 3. But to find coordinate point N, we need to find the equation of tangent to the curve at point O. So we have to differentiate that. So let's do dy dx. Let me do it over here. Dy dx, differentiate. As I differentiate 6, let me expand the bracket first. Your y will be 6x minus x squared. As you differentiate dy dx, you will get 6 minus 2x. We substitute your x with 3. Your dy dx will be 6 minus 2 times 3. Wait. You substitute x with 0, not 3, sorry. X is 0 at origin, and you're finding the gradient at origin. So your dy dx will be 6 minus 2 times 0. The gradient is just 6. Now, to form equation tangent, we use y minus y1. Your y1 will be 0, mx minus x1. In fact, because it passes through 0, you just think of it as y equals to mx plus c. Since your gradient is 6, you can write 6x. Your c, your y-intercept is just 0. Now, next, we know this point, midpoint N at x equals to 3. So when x is 3, your y is 6 times 3, which gives us 18. So therefore, the coordinate of point N is just 3, 18. All right, that is part A. Yeah, a bit of differentiation, then the rest are integration. Now, you're supposed to find area shaded region next. Shaded region, you can see, is bounded here by the x-axis. So your area should be integration of 6x minus x squared dx from 0 to 6. So we can integrate. When I integrate this 6, you increase the power by 1 to 6 divided by 2 is 3. This is x, 3 over 3. Lower limit 0, upper limit 6. Let's put 6 inside. 3, 6 square. 6 cubed over 3. 3 times 0 square. 0 cubed over 3. So answer, let's count. This will be 3 times 6 square minus 6 cubed over 3. Then the 0 don't need to type out. Obviously, answer is 36. Now, another way to double check the answer, of course, is by using a calculator. You can do integration 6x minus x square, lower limit 0, upper limit 6. Yep, still 36. Yeah, that's correct. Okay, lastly, volume of solid. Yeah, volume generated in terms of pi when the region bounded by the curve. Okay, let me highlight region bounded by the curve. So this is my curve. Region bounded by the curve. Okay. Straight line mn is here. And x equals to 3. X equals to 3 is here. So the region is actually here, the yellow region. Is rotated through 360 about x-axis. So when you rotate about x-axis, so you can draw a mirror image like this. There's a line. This is your curve. So it's like a cone. Then you subtract this region here. Yeah. So a bit ugly looking, but it's actually hollow inside. Okay. You're finding the volume generated by the yellow region. So a cone, right? This cone, as you can see, your y coordinate just now it was 18, right? This is 18. So the radius of your cone is actually 18. If this is 3, this is 6. The height of your cone is quite short, quite small. It's 3. 6 minus 3 is 3. Then you use integration to find this volume here. So I'm going to calculate like this. Volume of cone is 1 over 3 pi. Your radius is 18. Square it, your height is 3. You minus integration from 3 to 6 pi. Your formula is 6x minus x square dx. It's y square dx because I'm rotating about the y-axis. So the thing is, you cannot integrate this directly. Yeah? We have to use, we have to expand. You can't use composite function because there's an x square here. So the composite function of ax plus b power n dx is only valid if this is linear. If it's non-linear, we will have to expand. So 18 squared is 3 to 4. I'm going to write 3 to 4 pi here. This one you expand first. Take out the pi. 6 squared is 36. 36x squared. 2 times 6 is 12. 12x times x squared is 12x cubed. And then x squared power 2 is x power 4. Okay, so we only expanded. We haven't integrated yet. So when you integrate this, right, you copy x, increase the power by 1, 3. 36 divided by 3 is 12. This x power 4. 12 divided by 4 is 3. This is x power 5 over 5. Lower limit 3. Upper limit is 6. So let us substitute. All right. So put 6 inside. 12. 6 cubed. 6 power 4. 6 power 5 over 5. This is 12. 3 cubed. 3 power 4. 3 power 5 over 5. Okay, now just use your calculator and count. So we can use your calculator directly actually. For the first part, I think I'll just copy it, no problem. But for the second part, you can do the manual way, you can use a fast way. Fast way means I use a calculator. 6x minus x square, close bracket square. Lower limit 3, upper limit 6. Yeah, I got 648 over 5, or you can think 129305. Up to you. 129305. So take this answer, 324 minus this answer, you will get 1942 over 5. 1942/5 pi. Okay. Unit cube. All right. That's all. Okay, let's move on to question number 11. This is from the chapter Linear Law, Form 4, chapter 6. All right, so here we have a table that shows two variables x and y obtained from an experiment. So they are related by this equation, x power k equals y over a, such that a and k are constant. So we had to first construct a table of values for log 10x and log 10y, yeah, because you're plotting log 10y versus log 10x. So I'm going to just write over here, because of limited space, I'm going to write log base 10x here, log base 10y here. Okay, so use your calculator. Log, you can use this as shift log. First one is 1.74 equals 0.24. Okay, I think 2 decimal point will do. You don't have to use so many. 0.24. Keep going. Next one is 3.32. 3.32. That will be 0.52. Okay. Now, if you're lazier, you can actually set your decimal point for your calculator so that your brain don't have to go and round off the number. You take shift menu, go to number format 3. Number 1, fix the decimal point up to, let's say you press 2, that will give you 2 decimal point. You see, as you press equals, you automatically round off for you up to 2 decimal places. Okay, next one is 5.02. Yeah, 5.02, you should get 0.70, 9.19. Next, 9.19, you should get 0.96, 15.83, 15.83, you should get 1.20. Next one, 22.80. Okay, 22.8, you should get 1.36. Okay, keep going. Okay, the next one, we take 1.67. 1.67. This will be 0.22, 2.28, 2.28. This will be 0.36. Keep going. Next one is 3.32, 3.32, 0.52, 4.8, is 0.68, 6.3, 0.80, 7.61, 0.88. Okay, so now with that, we're going to draw. Now, before you plot the graph, right, it's best we calculate the gradient y-intercept from the graph, from the calculator itself. So let me show you how it's done. You can reset your calculator so that it doesn't round to the 2 decimal place again. So you press shift 9 to reset. You can press 3 to initialize, or press equal sign that you will reset back to the normal mode. Okay. Now you press menu here, press number 6 for statistics. Yeah, statistics, and then go to number 2, a plus bx. You will get the x and y value. So we're going to key in all the x and y value from the table. X is 0.24, the first one. Do all the x first. Next one, you have 0.52, 0.7, 0.96, 1.2, 1.36. Then you go on with your y value, 0.22, 0.36, 0.52, 0.68, 0.8, 0.88. Okay. All right. Now, what we do is we press AC, go to option, go to number 3 for regression calculator. Then you get your A, your B, your R. Now, A represents your y-intercept. Your y-intercept is 0.07. Right, let me write down. My y-intercept C is 0.075. Yeah, 0.075, very small value. B is your gradient. Your gradient is 0.605. 605. Gradient is your B, 0.605. So we know that our answer is going to be around there, close to this value. Okay. So, okay, the scale we have to use, we can see is 2 cm to 0.2 on the horizontal, 2 cm to 0.1 on vertical. So I think we have enough space. So we can start from 0 because your y-intercept is positive. Right? Because sometimes when you draw the graph, right, then you end up, the graph will cut below here. Yeah, your y-intercept is negative. Right? So that's why it's good to calculate this in advance, right? So that we know that our graph, yeah, whatever we draw can fit within the graph paper. Okay, so horizontal axis 0.2, 0. This is 0 0.2, 0 0.4, 0.6, 0.8, 1.0, 1.2. The largest is 1.36. So we have to go 1.4. You don't need to go more than that. So this will be your horizontal. Okay, horizontal axis. Okay, this is LGX. Okay, then LGY, your vertical axis is 0 0.2, 0.1. So we go 0 0.1, 0.2, 0.3, 0.4. It's actually shorter because you can see the largest 0.88 only. So we can go 0.5, 0.6, 0.7, 0.8, up to 0.9 will do. Yeah, 0.9. Okay, so this is your LGY. So let's draw your vertical axis. Start from bottom here. Draw a line upwards. Okay, so that is my y-axis. Okay, now let's plot the point one by one. Let's begin with the first point, 0 0.22, 0 0.24, 0 0.22, and 24. 22 is one small box here. 24 will be this point, yeah, 4. Because your axis or horizontal verticals are different, huh? Yeah, next one, 0. 0. Okay, sorry, your y is 0 0.22, your x is 0 0.24. X is 0 0.24, Y is 0 0.22. Sorry, so you got to do 0 0.24, 22 is this point. Okay, next one, 0.52, 0.36, 0.52, 52 should be here, 36 should be slightly higher, this point. Okay, next, 0.7 and 0.5, 0.7 and 0.52, 0.7, 0.52 is over here, slightly out. Yeah, 0.7, 0.52. Next one, 0.96 and 0.68. 0.96, 0.68. 96 and 68. Okay, I zoom out a bit. 9668 should be here. All right, next, 1.2, 0.8. 1.2, 0.8 should be this point here. Lastly, 1.36, 0.88. 1.36, 0.88, 36, 0.88 should be this point. Okay, now because I know my y-intercept is going to be 0.7075, you can use 0.07 because you can use 0.08. Yeah, doesn't matter. Up to you. I think if you want 75 is in between, right? Yeah, you can use 0.75. So let me adjust it. We'll see which one was better. Okay, I try to zoom out first. Right. Make sure you pass through as many points as possible. Now, it may not, your line of best fit may not pass through, number one, it may not pass through all the points. It may not even pass through the first and the last point, right? So as long as it's balanced, you can see, I think we need to move this up a little so that you can see you have 2 points below, 1 point, 2 points below, 2 points above. So this one I need to adjust a little bit. Right, so it passes through this point as well. Okay, let me see. Is it good enough? Right. Okay, right? 2 points above, 2 points below. Now, it may go below, may not be 0.75, you may get 0.7. It looks like 0.075, okay? It looks like right in between, 0.075, okay? You can even take 0.07 or 0.08. Okay, sorry, it looks more than 0.07. So I'm going to take 0.07, yeah? Closer to 0.07, okay? All right, so yeah. So that's my line of best fit. I need to find two things from the graph, gradient, y-intercept. My y-intercept 0.07. For gradient, right, I always like to use 5 horizontal boxes, meaning I pick 2 points. Please pick the point on the line, not the point from the table, because some of the point, as you can see from the table, is different. If you go and take, let's say this point, you draw together, obviously your gradient is different. The gradient is a lot higher. So I'm going to pick this point here, 1. At 1, it looks like this here. This 1.0 and 0.68. 0.68, right? You notice the from your graph is not 1, it's 0.96 and 0.68 from the table. Table values is different from what we got from the graph, okay? All right, so let's calculate the gradient. I'm going to calculate my gradient over here. My gradient from the graph is, y2, 0.68 minus y1, 0.07 divide 1.2 minus 0. Okay, use your calculator. Okay, we're supposed to get around 0.604, 605. So we can get rid of this. Menu. Go back to the menu. 1. Take 0.68 minus 0.07 divide 1.2 minus 0. Yeah, you should get 0.508. Okay, it's a bit far. I hope I am right. Okay, sorry, my mistake. The horizontal I'm using 1 minus 0. So it's not 1.2, it's 1 minus 0. So this is just 1 here. Yep. So it's nice number 0.61. Yeah, I'm supposed to get 0.605 and I got 0.61, which is quite good, right? Very, very close. 0.61. Okay. All right. Now, coming back to this question, I'm supposed to use the graph to find the value of H, A, and K. Now, you can see the equation is given here, the equation relating X and Y. So we need to convert this to linear form. We can do that by introducing log on the left-hand side and on the right-hand side of the equation. So I'm going to bring the K down, KLGX equals to LGY minus LGA, bring it over. Your LGY is KLGX plus LGA. Okay, so this is your big Y, this is your gradient, this is your big X, and this is your C. Okay, so you plot log Y versus log X. Your gradient from the graph is 0.61, right? I've got that 0.61 earlier. My gradient from the equation is K, so my K is 0.61. Okay, 0.61. So should be slightly different. You can't get, sometimes you can't get exactly the same. I got 61. Now, just now, if I were to use 0.075, then it's even more accurate, because if you take 0.075, right, you will be able to get exactly the same answer, 605. Okay, all right. So, but it's okay. I'll take 610 is good enough. Then you compare your y-intercept. LGA is 0.07. So we change from logarithm form to index form. You take shift log 0.07, you should get 1.175. Yeah, 1.175. Now, if you take 0.075, then your answer is 1.189. Yeah, so either way, so guys, you may not get exactly the same answer. You will get close, but not 100%, of course. Okay, all right. So, yeah, that's about it for question number 11. Okay, moving on to question number 12. This is from Form 4 Chapter 9, Solution of Triangle. So here we have two triangle, ABD and ABE. BCD, ACE are straight line. So you're supposed to find, they say, given that BC is 4.4. So let's label this as 4.4. And BC is 2/3 of BD. That means BD is longer. BD is 2:3. So your BC itself is 4.4. BD should be 6.6. So I'll label this as 2.2. Now, you want to find the length of AD. AD is opposite to this angle 48.3. So we have to use cosine rule to find the length of AD. Yeah, cosine rule works like this. We take AD square equals to 6.6 square plus 9.12 square minus 2, 6.6, 9.12 cos of the angle in between, 48.3. So use your calculator, 6.6. Make sure your calculator in degree mode, square plus 9.12, 9.12 square minus 2 times 6.6 times 9.12 times cos 48.3. Okay, so whatever you get, square root answer equals 6.830. Yeah, AD is 6.830. I'll give you answer correct to 4 significant figure will do. I don't have to give more. All right, that is the length of AD. Now, next, we are supposed to find angle BAE. So if you focus on this triangle BAE, let me highlight for you, erase this first. This is triangle ABE. So angle BAE means this angle here. So let's focus on this triangle. I can use sine rule because why? We know this is opposite to 4.3. This 83.3, the opposite side is 9.2. We use sine rule. When you want to find angle with the opposite side, another angle opposite side given, right? A pair of angle and side given, we use sine rule. So here we write sine angle BAE divide by opposite length 4.3 equals to sine 83.3 divide by opposite length 9.12. So your angle BAE is therefore, use your calculator, sine 83.3 divide 9.12 times 4.3. Whatever we get here, shift sine answer equals 27.92. Yeah, your angle is 27.92. All right. Now, then they say point B prime lies on straight line BC, straight line AB, such that BC prime equals to B prime C equals to BC. So if you focus on this triangle now, not this one, let me redraw for you the triangle. The next triangle we are focusing on is this. So it looks a bit complicated because of the 3 different triangles that we are looking at, right? Yeah, or 3 different parts that we're looking at 3 different triangles. So your BC prime equals BC, meaning we got to take this C is like your hinge. We're gonna flip it inside, right? This is a case of ambiguity, and question made it very clear. B prime lies on straight line AB, so that makes it quite simple. I know I have to take this and flip it inside, such that these two has the same length. This is your B prime. Okay, so you're supposed to sketch this triangle, right? Triangle A, B prime C. So just redraw this. Okay, I'll draw using this line. Okay, 1, 2, and 3. So it looks something like this. So adjust it a bit. There you go. So this is A, B prime, C. Okay, so remember this one we already calculated angle is 27.92, right? And we know we need to find ACB prime. I need to find this angle. But we know because of this ambiguity, right, when you flip inside, these two are isosceles. This is 48.3. So your angle AB prime C is 180 minus 48.3. That gives us 131.7. So if this is 131.7, we can now find angle ACB prime, which is 180 minus 131.7 minus 27.92. Okay, use my calculator. 180 minus 131.7 minus 27.92. So you will get 20.38. Yeah, 20.38. Okay, 20.38. Right. Okay. All right, that is part B. Let's move on to part C. Okay, the last part C, they say calculate the area triangle ABD using Heron's formula. Okay, I'm going to do it here so it's easier to see. ABD. You're finding ABD, sorry, we're going to rub this off because now we're focusing on this triangle instead. I'm going to just highlight this whole thing for you. I'm finding this. We know this is 4.4, so it's 6.6, 9.12. In fact, we know this length as well, 6.830. Now, in fact, actually, we can calculate this by using half AB sin C here, but because the question already say by using Heron's formula, so you're going to follow the instruction now. We're going to use Heron's formula to calculate this. So the first thing about Heron's formula is that we need to find what we call semi-perimeter. Semi-perimeter is half of your perimeter. The first side, maybe we start with 6.6. We add with 6.830. We can just 6.83. Then 9.12 divide by 2. Okay, use your calculator. 6.6 plus 6.83 plus 9.12 divide by 2. So this number is 11.275. Yeah, 11.275. So my advice is use small decimal point. Don't write 11.28. So because sometimes it may affect the answer. So we use the area as square root. S is 11.275. Then you sub in 11.275. Remember, the formula is given as this, a square root of semi-perimeters S minus A, S minus B, S minus C. So one thing is, for me, it's a bit puzzling is that Heron's formula is not given in the formula list in SPM, not given. So you need to know, they give formula for cosine rule, sine rule, and area triangle, but they didn't give Heron's formula. Partly maybe because they use back the old KBSM formula. The Heron's law is in the new KSSM syllabus, not in the old syllabus. All right, so you got to minus your A. Your A, let's start with 6.6, then 11.275. You minus with 6.83, then 11.275. You minus with the last one is 9.12. So another trick you can use is that, because we don't want to keep typing so many things in a calculator, so you can take this value, right? We already press equals. It's actually saved as an answer. So you put a square root, take the answer, open bracket, answer minus 6.6, close bracket, answer minus 6.83, and then answer minus 9.12. Okay, you should get 22.47. There you go, 22.47. That's your area of triangle. Okay. Okay, moving on to question number 13. Now, this is from Form 5, Chapter 8, Linear Programming. So the first thing is we need to form two inequalities. Okay, here the question says we have a recreation club that offers dance class and swimming class. The payment for dance class, swimming class are 10 ringgit and 15 ringgit per hour respectively. The classes are subjected to the following constraint. The first one is the maximum total time taken for both classes 20. So okay, you must read the whole question first, the whole thing. If you look at the part here, they say in a week, right, the club has allocated X hours for dance class, Y hours for swimming class. So if your total time, maximum time is 20 hours, so we know dance class is X, swimming class is Y. It does not exceed 20, so we write less equals 20, and maximum is 20. So that's your first inequality. The second inequality is this, that they say the total payment for both classes in a week does not exceed 250. So you have to pay 10 ringgit per hour for dance class. So it's 10 times X if you participate in X hours, and 15 for swimming class. So it's 15 times Y. Yeah, if you swim for 15 hours for Y hours, and this does not equals 250. Yeah, your maximum amount payable is up to 250. Now notice you can divide everybody by 5. As you divide by 5, you get 2x, 3y, 250 divided by 5 is 50. So I got 2 inequality already. Okay, now the first two, they say write two inequality in 1 and 2, done that. Next one, write constraint 3 in inequality form and describe in sentence. Okay, so this is very interesting because they gave us this line. So we need to calculate or form the equation of this line. To form equation of straight line, remember you use a coordinate geometry method, right? Because I have not enough space, right? So I probably would do this here. We pick 2 points. Maybe we take this first point. This is 0, 3. 3, 0. You take another point. Closest possible here. This is 5, 2, right? So we calculate our gradient. Your gradient is y2 minus y1, x2 minus x1. So your gradient is 1. And to form the equations, right, we can use y minus y1. You can pick any point. I like to pick 3, 0. This is 0. Gradient is 1. X minus 3. So your y is x minus 3. Okay. However, the region that you're talking about is above. So this is just the equation of a straight line. We need to identify the inequality. So it's above, right? Remember, it's always, when you shade the region, it's always based on y. You can see the region is above. So we should take y greater equals x minus 3 because it's a straight line. It's a solid line. It's not a dotted line. But when you want to describe, right, you have to, we've written the inequality, but you need to describe, right? Write the constraint in inequality form. We've done that. Describe in sentence. So describe in sentence, you bring the y over, bring the 3 to the other side. This would be less equals to 3. So to describe in sentence, we have to say, what is x again? X is the number of hours for dance class, right? We say the number of hours for dance class. When we say x minus y means x is greater than y, right? The difference between bigger minus smaller, right? We can say exceed. It is more than, right? It is more than y. Exceed the number of hours for swimming class. Now, less equals means it is not more than, right? By at most 3 hours. At most 3 hours. Or you can say the number of hours for dance class does not exceed the number of hours for swimming class by 3 hours. Yeah. Okay. So I like to use the at most 3 hours. So it's understood, right? Greater equals to 3. Yeah. Okay. So we got part 2 done. Next, part 3, we're gonna sketch the 2 more lines, draw the 2 more lines, and then shade the region. Okay, so for drawing this line, right, if you think it's hard for you to draw, mentally, right, we can use a table of values. I'm gonna do it here. X plus y equals to 20. Use a table of values. X and y. X is 0, y is 20. Y is 0, x is 20. Okay, do we have enough space for 20? No, I can't fit 20. So maybe we take 16. X is 16, y will be 4. So 0, 20, 16, 4. You can see 16 is over here. I'm going to use a straight line from here. 16 is over here. 16, 4 is here. 0, 20 is here. There you go. Do some adjustment. Okay. So my graph is almost done. This point is accurate enough. All right, so this is x plus y equals to 20. Okay, so we're gonna shade later because we need another equation. The second one is 2x plus 3y equals to 50. Yeah, 2x, 3y equals to 50. Use the table values, x and y. X is 0. 50 divided by 3 is an ugly number. 50 divided by 3, you can't divide exactly, so it's 16 point something, 16.7. Okay. But I can't go any further than that. So you can pick any other point. You want to put 16 also can. May not be a nice number. Let's say if I try with 16, 50 minus 2 times 16, then you divide by 3. Yeah. Okay, not too bad. 6. So this is 16.6. Okay, where is 16.6? 16.6 is over here. Okay. And 16.7 will be in between here. A bit hard to see. Okay, maybe I label x plus y equals 20 down here. Okay, 16.7 is this one. Okay, move it down. Make sure it passes through this. Okay, right. Looks a little bit off. Wait, I think I labeled wrongly. 16.7 is lower. It's here. 16.7. Yeah. Okay. Maybe a bit lower. Doesn't look. All right. I think it's all right. Okay. Right. So this is 3x plus 2y equals to 50. Okay. I got my three lines done. So now let's shade the region. The first one is less equal. So it must be below this line or here. Right. Second one is also below. Right. So it's below. So I think it's definitely not gonna be here. So it's gonna be below this quadrilateral. But one is greater equals. We already know that it is above this straight line. So your region of feasible solution is now within here. Okay. Region of feasible solution is now within here. So let's just label this region as R. Okay. All right. Now, next, we want to find maximum and minimum, the objective function. So it is given that average calories burned while dancing and swimming are 350 and 450 per hour respectively. By drawing the objective function, find the maximum total calorie burn. Okay, so I'm going to do my objective function over here because we need a bit of space. So first, you burn 350 and 450 per hour. 350 and 450 per hour. For dancing, the objective function is 350 times x. For swimming is 450 times y. This is k. So for me, I'd like to change this to y equals mx plus c to find out what is the gradient first. Okay, your y-intercept is a variable, but your gradient is fixed. So 450y is negative 350x plus k. 350 divided by 450 is 7/9. So the ratio is 7 to 9. So negative gradient means it's going downwards. So you're going to use 7 boxes. Right, I'm going to use a blue pen here. Easier to see. This is a blue pen. Okay, I'm going to draw 7 boxes. Here, 7 here and 9 horizontal. Yeah, vertical is 7, horizontal is 9. So that your ratio is 7 to 9. Okay, let me see. 7 to 9. Okay. All right. So with that, we can now we need to move this line. This is objective function. Let me write this here. 450x plus, sorry, 350x 450y. 350x 450y. I'm going to move this up and down such that it gives us the largest y-intercept. So let's draw another line. You have to use a ruler and slide it up and down. I'm going to draw another line that's parallel to it. Looks like this. To make it longer. Looks like parallel. Okay. Then I'm going to move it up. You see, as I move it up, at this, the edges, take the edges, you take this edge over here, the bottom part here, it's not going to give us the largest point, y-intercept. The largest y-intercept actually occur here, okay? At this point, let me move down a little bit. At this vertex here, can you see the sharp vertex here? It's at 10, 10, this one. At this point, it's going to give us the largest y-intercept. Let me just adjust a bit hard to see. So just a bit higher, a bit higher. Okay, so that you can see about parallel, right? Okay, it looks like about parallel. Okay, so as you move this up, right, at this coordinate here, I can see it's 10, 10. It gives us the largest y-intercept, meaning you will get the maximum calories burned if you swim for 10 hours and you dance for 10 hours, right? But you must fulfill the constraint. It must be well within the region R, right? So to calculate the maximum calorie, so first we say K is maximum at point 10, 10. So to find the maximum value K, we take 350 times 10 plus 450 times 10. Okay, calculator, 350 times 10 plus 450 times 10. My answer is 8,000. So the maximum amount of calories that you burn is 8,000. Okay, hope we can see this. All right. Okay, next question, question 14. This is from 4, chapter 10, index number. So here we have a table that shows information about 4 ingredients used to produce a jar of sweet. So calculate the price of ingredient P in the year 2018 if the price in the year 2022 is 12 ringgit and 10 cents. So let's focus on ingredient P, and I need to use 2022 based on 2018. So let me work it out here. So the price in the year 2022, you know, it is 12 ringgit and 10 cents. The price in year 2018, we don't know. We multiply by 100, answer is 1 to 1. So price in year 2018, we just take 1 to 1. You bring the 1 to 1 down, bring the P18 up. So 12 ringgit 10 cents times 100 divide 1 to 1. So my answer is just 10 ringgit. Nice number. RM 10 ringgit or 10.00. Okay, now then we know we need to find the price of ingredient S. Ingredient S in the year 2022, if the price in 2020 is 15 ringgit. So you have to use this one because this is 2022 based on 2020. So let me calculate here. Price in year 2022, we don't know. Price in year 2020, it was 15 ringgit. Now remember, when you decrease by 10%, the index is 90. So your P22 will be, let's take 90 over 100 times 15 ringgit. Yeah, 90 over 100 times 15 ringgit. Bring it up. Your answer is 13 ringgit and 15 cents. Yeah, RM 13 ringgit and 50 cents. Okay, now next, let's move on to part B. Yeah? So for part B, they say that it is given a percentage increase of price of ingredient Q. Now let's focus on ingredient Q. Yeah, ingredient Q. There are 2 years here. Okay, they say that it increase percentage of increase from 2020 to 2022 is the same or equal to percentage of increase from 2018 to 2020. So there are 3 years involved here. First year is 18, second year is 20, next is 2022. So this increment and this increment, they are the same. Now, from 2020 to 2022, increase by 30%. So I will write here 30% is 130. And they say increase at the same rate. So this also 130. However, 18 to 22, this is 18 to 22. Okay. This amount is 100 plus 3M. So remember, this is what we call a simplified chain rule. If I take 100 plus 3M, it will be equals to 130 times 130 over 100. These two indices, consecutive indices, you multiply together, divide by 100, it will give us the overall increment. So 130 times 130 is 169 actually, this one. You divide 100 is 169. Okay. So 100 plus 3M is 169. 169 you minus 100. You divide by 3 answer is 23. Yeah? M is just 23. Okay. Now, next. They say that calculate the next part. Calculate the composite index to produce a jar of sweet from the year 2022 based on the year 2020. Okay, so 2022 based on year 2020 means we have to use this. So now you notice this one 10% increase is 110, 30% is 130, unchanged is 100, drop by 10% is 90. So your composite index, we have to take 110 times the weightage is 7, 130 times weightage is 7, 100 times weightage is 2, lastly 90 times 4. Divide by your total weightage, 7724. Okay, so let's count. This will be 770 plus 130 times 7 plus 100 times 2 is just 200. 90 times 4 is just 360. Total weightage 7 plus 7 is 14. 14 plus 2 is 16 plus 4. This should be 20. I got 112. That's your composite index. Okay. Now, lastly, they say the cost to produce a jar of sweet in the year 2020, it was 30 ringgit. It's given that the total production cost in year 2022 was this amount, 263,222.40. And the selling price in that year is 40 ringgit. Determine whether a profit of 40,000 is achievable for year 2022. Okay, so here's the thing. We have to first calculate the cost in the year 2022. Yeah, the cost for one jar of candy in year 2020, it was 30 ringgit. So we find the cost in the year 2022, P22 divide P2020, which is 30 ringgit times 100. We know the composite index is 112, right? So that means the ingredient has gone up by 12%. 112 is 12%. So what is the new cost for one jar in the year 2022? So we take 112 times 30 ringgit divide by 100. I got 33 ringgit 60 cent, right? So your cost has gone up to this amount. So if you're selling at the price of 40 ringgit, so what is your profit? Your profit, let me write below here better. Your profit will be 40 minus 33.60. That will be 6 ringgit and 40 cent. Now, but you got to compare with your total cost. Your total cost, right, is now 200 over 1,000. This is profit for one jar of candy, right? I don't need to calculate how many jar of candy, because some people will take this one, divide by this to calculate how many jar of candy. You can. Then you multiply with the profit for each candy, each jar. You can do that. Or you can just straight use a ratio, right? Because one jar of candy, right? If you want to calculate, okay, what is the cost for one jar of candy? We take what is the number of jar candy produced? This is your total cost, 263,222.40. You divide by cost per jar. This will give us number of jar. Then you equate it with your profit that you're looking for. You want to calculate the total profit. See whether your profit exceeds 40,000 or not. You divide by profit per jar. Profit per jar is 640, right? So let's take this one. 263,222.4 divide 33.6. So that will give us 7,834 jar. Yeah, if you want to calculate this as 7,834 jar. So that is the number of jar produced that year. Then you multiply with the profit per jar. One jar you make 640. So your total profit is 5137.6. So RM 5137.60. So that's your total profit. Now, does it exceed 40,000? Yes, it does exceed 40,000. So determine whether this is achievable. So answer yes, it is achievable. Yeah. Okay. Interesting. Okay, this is the last question, kinematics of linear motion. Okay. Here we have a velocity of a particle that moves along a straight line is given by this function, right? You're finding the time when the particle stops momentarily. Very simple. A particle stops momentarily when your velocity is 0. So we take 3t squared minus 14t plus 8, let it be 0. Okay, 3 times 8 is 24. Factor of 24, I should use 12 and 2. 12 and 2, negative here. Minus 12 minus 2 is minus 14. So your t is 2 over 3 or 4. Yeah, two answers. All right, so that is part A. Second one, calculate the initial acceleration. Okay, you have to differentiate velocity to get acceleration. Differentiate this, you get 60 minus 14. When you start the clock, t is 0. So if you sub 0 inside, this is just negative 14. So your initial acceleration is negative 14. B Roman 1. Then find the minimum velocity. Minimum velocity happens when your acceleration is 0. You keep going until you stop. Your acceleration, you cannot go anymore. Then you cannot increase your speed anymore. Then you stop increasing the speed. The gradient, the acceleration goes to 0. Then it just reduce the speed. I have to say this because I hope you understand. We are talking about minimum velocity doesn't mean you're traveling at a slower speed. Minimum velocity means you're going to the left at a faster speed until you, faster speed. So it's not really changing direction. You just go too fast and then you just slow down and then you change direction. Can be here. So diagram wise, right? If you draw the graph of sine, you have to understand this is your speed versus time. This is your maximum velocity. This is your minimum velocity. For both cases, the gradient of the graph is your acceleration. Your acceleration is 0. Okay, so we let A be 0. When your A is 0, 14 divided by 6, you get 7 over 3. So take this and sub inside your velocity. So 3, 7 over 3 square, 14, 7 over 3 plus 8. Okay, use your calculator. I'm going to key in 7 over 3 first. Take 3 times answer square minus 14 times answer plus 8. I got 25 over 3. 25 over 3 is actually negative 8, 1 over 3. So if the question asks for maximum speed, then you modulus it, write your answer as 8, 1 over 3. Okay, all right, now next, part C. Calculate the total distance travel until when you stop for the second time. Okay, now for me, I do a sketch. You can see this is a velocity time graph. It goes like this. This is 2 over 3. This is 4. So your total area under the graph for velocity time is the distance travel. But you notice, right? Part of the graph is above the x-axis or t-axis. Part of the graph is below. The one below is negative. So we're going to modulus it to make it positive, right? Or you can put a negative in front. So what we can say is that your total distance is, we can use definite integral. You integrate from 0 to 2 over 3. Your function is 3t squared minus 14t plus 8. Now, I know some people may use what we call, you find the displacement function. First, you integrate v to get your s, then you sub in the coordinate, the point 1 by 1. You can do that, right? So I plus, this one is going to be negative. So you can modulus it, or you can add a negative, up to you. So, okay, I just put modulus. This will be 2 over 3 to 4. 3t squared minus 14t plus 8 dt. Okay, so as we integrate, this is t power 3 divided by 3. T squared divided 14 divided 2 is 7. This is 8t. From 0 to 2 over 3. This one you modulus t cubed minus 7t squared plus 8t. This is from 2 over 3 to 4. So let's put 2 over 3 inside. 2 over 3 cube, 2 over 3 square plus 8, 2 over 3. Now here's the annoying part. Yeah, you want to put 0 inside. Yeah, very annoying. So then you add the modulus, put 4 power 3 minus 7, 4 power 2, 8 times 4, minus again 2 over 3 cube, minus 7, 2 over 3 square, 8, 2 over 3. Yep. Now, here's the advantage of using a calculator. We can integrate the original function, 3x squared minus 14x then you plus 8. Your lower limit is 0, upper limit is 2 over 3. That will give us 68 over 27. I'm just going to write 68 over 27 first for the first answer. Okay. The second answer, you're going to modulus it. It's going to be negative. So let's just change the limit. This is from 2 over 3 to 4. Okay, delete this, change to 4. Your answer is negative 500 over 27, negative 500 over 27. So it's basically 568 over 27 you add together. When you modulus, it becomes positive. Okay, let me write again. 568 over 27. Or you can change to mixed number, 21, 1 over 27. 21, 1 over 27. For me, mixed number makes more sense. So you know you travel about 21 plus meter. Okay. Yep. All right. That's the end of our discussion for this MRSM paper. Thank you for watching. Yeah. Hope to see you in the next video. Okay.